I think I was muted.
Ah,
Hello,
how's it going?
everyone. This is our first webinar of the year. We still don't have anybody on the webinar yet, so we're just gonna give it a couple of minutes to get started. How are you, Linda?
Sounds good. I'm good, thank you.
Good.
How are you?
Yeah. Good. Good. Good.
Awesome.
Let's see if we can. Okay, we have 7 people. Hello, everyone. How are you guys today? This is our first webinar of the year. It's going to be based on fourth axis. Before the webinar, it's important that you guys know that everything we do has a cadence and a specific order. So normally we send you a survey. We ask you what you want to learn about our product. You let us know. We write an article that you will be able to find in bobcat.com news right here. The article will cover details about what we're going to be doing today on the webinar. And after that, after the article, we'll discuss the article with you on the webinar. Okay, so we have Andrew. Hello, Andrew. How are you? Now, Andrew just wrote to us through the chat. Remember that what makes a webinar and what makes it different from a video is your interaction. It's very important you guys interact with us. Let us know any questions, anything you guys need to know or want to learn about the product, or if we're going too fast, if there's something that you miss, let us know in the chat so we can help you out. Okay, so hello, Martin. How are you? Amazing. We got some interaction this time. Yeah, I think like it was 2 or 3 webinars ago that I was like, anybody has any questions? Hello, Timothy. How are you? Okay, before we get started, I'd like to take some time to introduce our new customer success director. She's just came into the team. Her name is Linda, and well, I think nobody
Hi,
can do
everyone.
better to introduce but herself.
Thank
So
you.
here she is.
Thanks, Tatiana. Good afternoon, everyone. It's great to be here with you all today. As Tatiana did mention, I'm the director of customer success at Bobcat, and I am new to Bobcat. However, I am a seasoned employee of Harris, and I've been with Harris Computers now for about 6 years. And my hope for Bobcat is that I can join the team and participate in customer success opportunities and engagement, and connecting with our customers, and helping them to succeed in their own business. So thank you very much for the introduction, Tatiana, and I am happy to be here on my first webinar.
Well, amazing, amazing, amazing. So we got some interaction. Marty has been waiting for this one, and Andrew wants to know how to do this one. So we'll get to those. Yeah, we prepare a really good webinar for you guys. The idea is to cover a little bit of everything. We're gonna start with the basics. We're gonna start with some indexing. Then we're gonna do some wrapping. Then we're gonna see the differences between 4-axis standard and 4-axis pro, where they make what really it's the big difference between them. And after that, we're just gonna go into a helical gear at the end. So, Andrew, yes, that's part of what we're gonna do today. Okay, let's get started with some indexing. So, I'm gonna start with the basics. Hello, Gary. Hi, Gary. How are you? Again, love the interaction. Write everything you guys want to write. And any questions will be here. So, we're gonna get started doing an index operation. So we're gonna go to camp defaults. Always, we're gonna go into the country first. Right click on camp defaults, new job, milling in this case, and we're gonna go with a 4th axis machine. So we're just gonna pick the generic Bobcat 4th axis post processor, but as you know, there's several post processors. We're gonna go to our stock wizard. Now, we're gonna pick this geometry. We're gonna press Nets. Now, it's important to select the solid, because this is the solid that we're gonna utilize to compare in our simulation. So in our simulation, we can compare the solid versus the final result. So it's important to pick this. Now, we're gonna pick what is the shape of our material. So we're gonna start with a cylindrical shape. We're going to work from the x-axis, and we're going to calculate stock. So the system will automatically calculate the stock for us, and we're gonna increase the diameter, like around 15. Okay, so we have our stock ready. The next thing, we're gonna press nets. If we're rotating around the x-axis, it's gonna be A. If we're rotating around y-axis, is gonna be B. So we're gonna set up our origin right here. There is. We're rotating around the x-axis, and we're gonna press OK. So at this point, we did the material setup. Everybody's good? Everybody's ready?
Tatiana, if I can just stop you right there.
Yeah.
Gary is having some issue. He just sees the black screen. He doesn't seem to see your screen share.
Okay. Let's ask the rest of the guys. Are you guys able to see what I'm doing, or is only Gary? Right now we're doing the material, the stock setup. Just wanted to make sure that you guys are able to see.
I can see it.
Okay,
And
Andrea can
Andrew
see
can
it.
see it.
Hmm.
Marty
Okay,
is saying
so
it's all good.
Gary, maybe try from another link. If you if you go to Bobcat and you go to training events, just click there, enter your information, and you should be able to see it as well. Okay. Okay, so Gary, just try to do it for another link. Maybe that will work.
Oh, it's on now. He
Okay,
said
it's
it's on.
not
He
perfect.
reloaded the page. Perfect. Okay.
Okay, so we have our cylinder right here. What we're gonna do first thing, it's set up one index. So we're gonna right click right here, additional features, and we're gonna do add an index. We're gonna pick one of the faces. This is gonna be index number 1. We're gonna press OK, and now we have positioned that index. What I'm gonna do, I'm going to right click on that index, and we're gonna do a facing operation. We're gonna select that geometry right here to this position. You know what? Let's do cancel. Let's not do facing. Let's just do a pocket operation. So select geometry. We're gonna pick this. Now, something that I don't know if you guys work with Bobcat before, and if you notice, I just click on one of the edges of the surface, and the selection happened automatically. I did not have to do a shift and a selection or having to strat the edges. All that's gone. All we have to do is pick the top and the bottom of our packet, which will be here. There we are. We're gonna press, and we're gonna tell it that it's an open packet. Notice this. So just by doing this, the system will know it's an open packet. You don't have to enter that information. There is. Press OK. And we're just going to do a rough operation packet. Okay, so another big change on the system is the tool crib. In prior versions of the system, we had separate bots for the tool crib. This meant if you wanted to pick several tools that you were going to use, you have to pick one by one. Close, open, close, open. In this case, all your tools from the tool library will be available right here. And if you want to take one of your face mills, let's spit a smaller face mill, this one. You just have to drag it. And if you want to pick like different kind of tool, all you have to do is you can add them to your tool crib without having to do much. And you can add several tools at the same time or pick many of the chain select or multi-select and just drag them into your tool crib. So we're going to use this one, the face mill. Okay, next I'm going to do just a normal packet. We can do a morph spiral. We're going to go 2 steps. We're not going to have a finishing operation, just packet compute. Okay, we can do a quick simulation to make sure that everything's been done correctly. Is it doing it like an open operation? I don't think it's doing an open operation. Let me check the geometry. Oh yes, it is. It's taking the open chain. Now, once we did this, I want the same packet to happen here, here, and here. So we're going to rotate it every 90 degrees. I want to ask the people that we have on the webinar today, what feature, what functionality will we use to rotate that operation on Bobcat? I don't know if I have any experienced users here. Okay, so we're
No
gonna click
responses
on.
from the chat.
Perfect. So we're gonna click right here, and we are going to. Okay, how do you make sure that the tool plunges outside the stock? That's a really good question. It's already plunging outside the stock. The way we did it was on the geometry selection, Andrea. On the geometry selection, by the system understood the starting position based on the stock. But we have the ability to just enter it. If you enter a top position higher, then you can do it. David, thank you. You can translate or rotate. So we're going to rotate around this. So to rotate around this, do we have a line? Yeah. We're going to right click here, additional features, and we're going to do add a toolpath pattern. We're going to rotate next 3D option. We're going to rotate 90 degrees. We're going to make 3 copies. And we're going to pick around this line here. Okay. So the thing about what we just did is that we don't have to do each packet again. All we did is we did one, which was the top one, and then we did a translate toolpath pattern. Okay. Are we all familiar with toolpath patterns? Are we good with that? Everything good with that? Okay, Andrew has a question. Just to be clear, I want to use face mill or do something to start off the side of the job to cut the toolpath, still plugging into the material. So when you're doing face mill, it's cutting into the material right now, like when you're doing parts, even if you set up a higher top, a higher position to start. Okay, let's see. Facing, select geometry, stock type. It's a cylindrical stock. Hmm. I wonder how the stock pick button. Okay, so we have a facing out there. You see how it's starting from outside of the stock? Here's the stock. Let me put something here. Okay. So you mean this? How do you manage that? Okay. On the facing operation, you go off workpiece and then you tell, can we do that off the packet toolpath? Yes, we can, Andrew. The way we can do this, we will have to generate a bigger rectangle for the system to understand that we're coming from the outside. Yeah, that would be the way to do it with the packet system. So what we will have to do it in the packet, we will strat the edges of this one and do a compensation. So let's do it. UCS, let's do planar face right here. We're going to 2D, strat edges, there. Now we have a red, we stratted the edges from that area. Let's go to layers. I wanted to create a layer. Strat edges on this one. Okay. Now we have that wireframe. Can you see it, Andrew? So what we're gonna do here, we're going to use 2D. We're gonna offset. We're gonna offset this one to the right. Like the amount of that will go above the beyond the material. So let's go like around 15. And we're gonna make sure that that wireframe is a dotted line, so it's an open packet. And we press OK. Now that we did that, if we go back to the CAM tree and we select our packet to be around this one, it's gonna go. Let's see if it's engaging from the outside of the material. Let me change the packet type. Let's go. Even though we're selecting this geometry from, so there is, do we have a extend feature? Yeah. Let's look at the stock and this bucket. Okay, we're still, so Can you rotate the toolpath 90 degrees? That's what we did. We rotated the toolpath 90 degrees with this, but it's similar. Yeah, that's what we just did. You want it to go this way or this way? This is where you do that, right here on the angle. Perfect. You see, you can change how you want it to be, 0 degrees. So if you want to do it on the packet and have control over the size of the packet, you will have to generate new geometry in order to do that. Okay, perfect. So we're good with this. Amazing, and Andrew's participating a lot. Okay, perfect. Let's keep going. So da, 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 da. Let's go to a UCS. Go back to our normal UCS, and let's go to our layers and bring back our solid. So we did our packet, or we can do our facing. We have any of them, and since we did it on the index, notice that I did the toolpath pattern under the index. So everything I built on this index system will be rotated 90 degrees, as you can see here. So we're just gonna leave, we're not gonna do the packet, we're just gonna leave the facing operation. So it goes on each one of the toolpaths. Any questions at this point? Are we good? Okay,
Seems all good.
perfect. Now we're gonna tackle the drilling operations. For the drilling operations, we're gonna use a feature that is pretty cool. I don't know if you're using it right now. We're just gonna go drill hole. We're gonna select the geometry, and we're gonna change from standard drill to multi-axis drill. When we do this and we select our solid, what's gonna happen is the system will understand the angles of each one of the holes. Can you see that? So we press OK. We're gonna click Nets, and the Nets trick, it's right here in the group retrads. We have to make sure that we're setting up a cylinder shape for the group retrads. If not, it's not gonna look good. And our rotation axis is the x-axis. So we're gonna do x-axis rotation. We're gonna go shortest distance, or no, tool orientation, okay, 82 radius, perfect. We're gonna do the strategy is gonna be drill. Done. We wanna do that for everybody else. So we're gonna go to closest. And notice that it's showing me each one of the holes that we're doing. Some of the holes will apply, some won't, so we just need to make sure to get the ones that do apply. So this one, machine strategy, that's perfect. Then we're gonna do this ones, let me see. Yes, perfect. We're gonna do machine strategy, drill. So we have the 6mm, the 10mm that apply the, let's see this one, the 4, perfect. This one's done, and this one's due. No, this one doesn't either. So we're gonna compute, and we're just gonna get rid of the ones that, oh, that's my problem. Let's go back here. Yeah, delete, delete, delete. Let's do it one more time. So we're gonna right click here, drilling, select geometry, multi-axis. Okay, next we're gonna group retreads, cylinder, x-axis, and I forgot to click apply material to all. So that was my mistake. So we need to apply that to all. That way, each one of the holes will have the cylindrical retraction. Okay, and now we just need to make sure which one is which. So we just need to make sure which ones are which. This ones don't apply. This ones do apply. Perfect. This one's too. Perfect. So this, we're gonna add the drilling and apply to all. Perfect. And then we're just gonna compute. And we're gonna get rid of the ones we don't need. Okay. As you can see, all the drill holes have been generated for you. Well, we have an extra one that does not apply. Let's see which one is it. This one's delete. Okay, there it is. Any questions about the drilling? Is this clear? How we were able to do all the drills at the same time? Okay, good. I think this is a very neat trick because not everybody knows that the system can recognize the angle position. And if you add the cylinder rotation, basically you're ready to program the whole thing. Perfect. Okay. Any questions about indexing before we move on?
I think
Okay.
we're good to move on.
Yeah. Okay. Now we're going to do a wrapping group. Yeah, it is. Andrew says here is similar to some three-axis stuff in Fusion 360. To be honest, most systems are gonna look very similar. You know, most systems today are gonna look very similar the way they operate, and some of the toolpaths are even gonna be the same. So it's just about the amount. I think that's where Linda makes a difference. You know, the amount of help and resources and work that each company is gonna do for their customers. That's the big differentiator. Not that much functionality, but actual resources and help that you can get from the company. That's why we're
Exactly.
trying to get better. Yeah. Okay, so we're gonna do mill, new job, mill, fourth axis, guide. This is our solid. We're gonna do a cylindrical shape under the y-axis. Calculate stock. There is. We're gonna give it. No, we don't need to give. And our direction will be origin right here, and we're gonna rotate it around X. Right here, bam. There is XYZ. Okay, perfect. Now, there's two ways to do this. When you have the geometry flat, and when you have the geometry right here, already wrap around it. So we're gonna go over both. We're gonna right click right here in machine setup, additional functions, and we're gonna do add a wrap group. Okay. Now we're going to tell the system that the geometry it's already wrapped. Okay. We're gonna use the diameter. We're rotating around the x-axis. We're going to press OK. Now, under the wrapping group, we're going to go to Axis, select Geometry, and we can pick the inner shape if we want to do a packet like this. So it will generate the chains, or we can pick one of the lines around the part like this. If we want to do a profile. So let's select the profile. Okay, and then we have one chain. Can you see it? Now, since on my wrapping group, I selected that the geometry was already wrapped, the system will do the unwrapping for me. So this is my geometry selection. We're gonna do a profile finish operation. We're going to use, I don't remember what's the size of this. I think it's like half of this. We're gonna compensate to the right hand side. Just one depth. We're gonna compute. Oh, no, it actually needs to be a lot more. But let's do a simulation really quick. We're gonna generate G-code. Here's the G-code. Here's the wrapping operation, as you can see. So we're moving around X and A at the same time. We're just moving X. Our Z value is just 1. So it's a fixed Z value, and we're just rotating around the A axis. Okay. Of course, we will use a bigger tool. I wasn't sure of the size of the tool. We'll use a bigger tool and we'll use profile through the middle of the part. Any questions about how to use a wrapping group when the part is wrapped? Now, the other way to do it, we're gonna do it now with a part. Let's say we're gonna start a new document. We're gonna change our UCS this way, and we're gonna create a cylinder that is 2 inches diameter, 1 radius and height, and we're gonna put it right here on this area. Okay, we're gonna come back to the top, and we're going to unwrap this. So we're gonna, the feature that I want you guys to pay attention, this is the way you unwrap geometry. You go to 2D, unwrap, and by clicking this, whatever cylindrical shape you have will be unwrapped for you. Now, let's go to layers. We're gonna have a solid layer, which is this one. Oh, we have a new conceptual menu, so we're just gonna move it to the solid layer. Perfect. This is gonna be our canvas. So we're just gonna, instead of a profile, the situations where, oh yeah, definitely you can do a packet. It's definitely you can use the adaptive feature to do a cleanup operation. I just wanted I just wanted to get the concept right, but Andrew, you're right. The proper way to do it, instead of doing a profile, well, depending on the tool too. But instead of doing a profile, will be actually do a packet or a cleanup operation right there. Okay, so let's go back here. Now, in order to draw on this wrap geometry, I'm going to create a new UCS on this position. Perfect. Now we're gonna utilize this wireframe to do 4 touches, but on out of a flat geometry. So we're gonna do 2D. We're gonna do an arc right here. Let's put an arc around here, and let's make it 0.5 there. Let's put another arc here, and we're gonna do a line that comes from center to center. Okay. Now we're going to wrap that on 4 touches. It doesn't mean that we have to draw it around the cylinder. We can use the wireframe. So we're gonna go into Camtree, layer. Let's go back to the cylinder. And let's go to the normal UCS. New job, mill, 4 touches, wizard. We're gonna do our cylindrical shape. Stop around the x-axis. There is. Perfect. Now, we're gonna go into 2 axis, machine setup, additional functions, and we're gonna use wrapping group. Now, this time the geometry is not wrap, so it's very important that we don't have that selected. Okay, we have our stock rotating around the x-axis. And one of the mistakes that we do in 4 touches is we go back to pick our feature right here. Now, when you're doing a wrapping group, you have to pick it from the wrapping group. If not, it won't be affected. It won't wrap. So when you're picking your feature, your functionality, it needs to be done from your wrapping group. So we're gonna do wrapping group, 2 axes, and we're gonna do just this profile right here. No, not the whole thing. Line 3. Actually, that was the line that I wanted. So let's remove the auto selection and let's just do this one. There it is. We're gonna do 1/4 inch depth. Perfect. And in order to come from the outside, we're going to utilize our extension feature, 50% of the tool. We're just gonna do a profile, finish, and we're gonna compute. There it is. It's gonna show us what's happening from a wrap perspective. Now we're gonna do from the wrapping group, we're gonna do drill hole, select, we're gonna pick this one and this one. We're just gonna tell the system that we're gonna compute. Oh no, yeah, here I should have used indexing on this one, so delete. Yes, that one is only for 2 axis operations, so 2 axis, select, and we're gonna just do these 2 profiles. There they are. There it is. We're just gonna do a profile finish around them. Did I pick it? Yeah. Now let's do a simulation. So the difference here is that you not always have to have the solid. You can definitely do 4 touches just out of the wireframe, like we did right here. Any questions about wrapping before we move into 4 touches Pro? So remember, you can wrap from geometry that's already wrapped, or you can wrap from wireframe, flat wireframe. and the system will do the wrapping for you. So we're good with wrapping? Okay, it seems that we're good. Let's go with this one now. Now, there's times where wrapping doesn't work or does not apply. Right here, we did a wrapping operation. Okay, we did a wrapping operation and we did a two-axis operation right here. By looking at this part, who can tell me what's the problem? Why wrapping doesn't work? Anybody? What's the problem with wrapping here? Let's look at the part. The problem here is the angle. So if we do a quick simulation of the profile finish, backplot, and we go around it, progress, there. As we're coming to this area, right here, let's just go back, pause, there. Wrapping only works exactly, Andrew, you were on the spot, exactly. The angle of the walls. Wrapping works under a constant z or a constant y. It does not allow for the angle. So that's when 4-axis Pro will make a difference. That's one of the biggest difference between 4-axis standard and 4-axis Pro, and it's being able to interpolate on the 4-axis simultaneously. That's one thing. The other one is adapting to surfaces. So this part can be programmed in 4-axis standard and can be programmed in 4-axis Pro. It can be done in both ways. Now, with standard, we will have to do an index, rough, index, rough, and after that, we will have to do a rotatory toolpath. Now, again, here, our G-code is generating only two axes, which will be A and Z. Are we gonna be able to finish the part? Yes. Is it gonna be good? Is it gonna look good? Not so much. And also, it's gonna take forever. It's gonna take a long time to be programmed correctly. So what 4-axis Pro does for us is this. It adapts to the surface like this. There's gonna be around a difference of an hour on runtime, like an hour of runtime, and the part's just gonna look way better that what you will normally expect from a rotation. Also, the roughing operation, it will be easier as well, because the roughing, we can generate a roughing operation that is not indexing. So since it's not indexing, it's adapting to the shape of the surface or the shape of the solid, and we're gonna have a much better part at the end of the day, because the roughing is going to do a lot of the work of the finish, and the amount of finish operations or the yeah, the amount of finish that we're going to have to do is less because the roughing is going to look better. Okay, you have 4-axis Pro, Andrew, so you have the right you have the right product. Actually, one of the biggest things that we're going to get away a little bit of 4-axis here. One of the biggest pros, or one of the biggest advantages of working with 4-axis Pro is that you get the 3-axis premium toolpaths. I'm gonna explain. Right click. So we have 2-axis, 3-axis, 4-axis rotatory, and then we have multi-axis. The multi-axis toolpaths are surface-based toolpaths. Anybody here can tell me what's the difference between a mesh toolpath and a surface base? Okay, I'm gonna go really quick and explain. I think I have that here in demos. And yes, this is it. Okay, so this is a part. This part, we were able to program it with a customer using a mesh toolpath and a surface-based toolpath. Everybody knows the equidistance offset. Equidistance offset, if you've been a customer of Bobcat, you utilize the equidistance offset. And the equidistance offset does a marvelous job. But if you utilize Bobcat before, you've seen this. Has that happened to you? Like those little markings? Yeah, STL mesh. STL is a mesh. So exactly, Andrew, to tell you what happens, equidistance, slice planar, Z-level finish, all those are mesh toolpaths. So what the system does, it takes that surface, it takes it into the background and converts it into an STL. And out of the STL, it generates the toolpath. That's why sometimes you're gonna find some markings on some shapes that are not exactly on the surface, but they're gonna show up on your part. Has that happened to you guys? Because I'm curious. I seen it. I work with the machines, but I'm not in a shop every day. I'm in an office, so you guys can tell me better. So this is what happens. Yeah, yeah, it is an issue. What's gonna happen is when you use the surface base. Okay, Marty has that issue too. When you use the surface-based toolpath, that it's reduced substantially. This is the surface-based toolpath. Can you see it? So that little shape that we had, that those little markings that we had, they go away. And not only that, like if we go to bobcat.com, bobcatsupport.com, we built this little website where we're displaying some of our customers. Yeah, premium. It makes a difference. So if you go to customers right here, and this is a big invitation for all of you guys. If you want us to showcase your work, we're gonna showcase it on our social media. We're gonna put it on our website. Send us your parts. Send if you do a part, you're proud of it. You want everybody to look at it. I did it with Bobcat. I'm happy. Send it to us. Send it to my personal email, trojas at bobcat.com, ROJAS. And here's that part. Let me show you guys. I think I have it right here. Pro versus premium. Here it is. And at the end of the part, we can see the difference between pro and premium on the finish operation. No, I think I need to go a little bit. Let's do it again. And it right here. There. Can you guys see it? So when you use your premium, let me write it. Rojas at Bobcat. That's my email. Feel free to send me any questions, any feedback on this webinar. Let me know if I'm doing it right. If you like the webinars to be different, and please send us parts. We'll showcase them on our website, on our social media. But what I wanted to show here is the big difference, the big result difference between Pro and Premium. So if you guys have the premium system, go for the premium. Use the premium. Use the surface-based toolpaths. So if you right now have a fourth axis software, our software fourth axis standard, my suggestion, go to fourth axis Pro, because when you get to fourth axis Pro, you get the fourth axis premium. Okay, before I take more time, I'm gonna go and solve Andrew's problem, which is how to do this one. So the functionality that you're gonna use is gonna be four axis rotatory. Okay, so we're gonna do four axis rotatory. We're gonna select our geometry. Make sure that we select it, press OK. And we're gonna use this one, advanced rough and advanced finish. Yeah, same, Frank, they were the same distance, same step over, everything. It was the same. Frank is asking if we set up the toolpaths with the same parameters. Yes, we did. You can see it here on the side by side. Let me bring them both up. There they are. Same distance, same everything. So yeah, there's going to be a huge difference when you go to Premium or you go to 4-axis Pro on your 3-axis surfacing. Okay, perfect. Let's go back to our part. Let me make sure, what tool did I use here? I use a 7 and a 6. And what distance? 1.5 and 0.5. And here, 0.8. Okay, so we're gonna define our tools. We're gonna use the 7 millimeter tool. We're going to do SIG. We're rotating around the x-axis. Climb mill. We're gonna go, this is gonna be 1. We're gonna go 0.8 right here, our step over. So here's how deep we're going per pass. Now let's go 0.8 both. This is our distance. Everything's gonna be shown with a picture. Nets. And then we're gonna do our finish operation, which is gonna be, I think it was a 6 millimeter. 3. Nets. And we're gonna have a depth per cuff of 0.5. Compute. Now, Andrew, in what version of Bobcat are you in? Because I think they added this functionality to the 4-axis rotatory after version 34. So if you're after version 34, you will be able to access this functionality I'm showing right here. Oh, V11, you have access to this. Okay, so here's the rough. And here's the finish. Let's generate only this G code. And let's see our simulation. SolidWorks 2014. This is just advice. At any point, if your computer breaks or anything, SolidWorks won't won't give you your license back. So please take care of it. Okay, and then we're gonna do our simulation. Yes, it works. Like I said, as long as it works for you. Okay. Everybody, we're coming to our end of our webinar. I hope I was able to enlighten you with some new information, things that you didn't know. How can you stop the drilling and plugging? The way I will do it, to have more control of what the toolpad's gonna do, I will use the surface toolpads. So I programmed this part two ways. The other way I did it is by doing this, utilizing the surface toolpad. With the surface toolpath, you can increase the distance, so the distance comes from the outside, and it doesn't break and plunge your tool. So I will use this multi-axis to have a little bit more of a gouge control situation, Andrew. Now, tomorrow around 9:30 in the morning, you guys are gonna get an email with a survey asking you what do you want to learn about the product. Okay, so we're gonna enter some subjects. You pick whatever subject you pick. What we're gonna do, we're gonna write a blog about it. Read the blogs; they're very helpful. They're gonna help you understand this process better. And on January 31st, in exactly 2 weeks from now, we're gonna have another webinar where we're gonna cover specifically whatever you guys chose. Okay? So thank you very much for your time. Thank you very much for working with us and trusting us. Uh, we had a lot of participation. Normally, these webinars we don't people don't participate that much, so I'm very thankful. And well, I hope I was able to enlighten you and give you some new information you guys didn't have. You want to learn how to machine for an STL file? I'm gonna add that to the survey, Andrew. How to work from an STL file. Because actually, there's really neat features on the ART system to work from an STL file. Let me show you really quick. I think I have this on ART. Uh, I think I did this one. Yeah. Do you see this one? This is pretty awesome. We did like a mold out of the STL. Okay. And using the art, I can actually change what size, what part of the mold I'm gonna be looking at. So let's go to here to the edit, and I can do, instead of change the plane, invert there, apply, okay, and now I'm doing the front. And using the front, then I can use the packet for the other operation. Oh, it's the other side. I have to put it on the other side. Okay. Oh, yeah, we can definitely cut. Yeah, the art will be pretty good because we can mix art with STLs. Also, we can use the multi-axis functionality to do rotation around an axis using an STL. So there's a feature where you can use the STL as a gouge check and select the surface of a cylinder to cut around this. You tell the system that you're going to cut around a cylinder, but you use the STL as a gouge check. That way you can use the surface toolpaths also on an STL. So that's something that you could do as well. It's, in reality, you could do crazy things with Bobcat. I've been working this year. It'll be my 20th year with Bobcat, and it's just incredible the things you can do with it. A brief lesson on how to use fourth axis for your horizontal mill will be nice. Okay, perfect. Okay, so I'm gonna, as the options, I'm gonna put STL machining and second part for four axis as options for the survey. Okay? Thank you very much to everyone. Thanks for participating. Thanks, Linda, for being here.
Thank
And
you.
well, thank you for working with us. Have an amazing day. See you guys.
Have a good day, everyone.